Look up at the sky. Doesn't matter where you're standing or what patch you pick. Count the stars you can see. Then imagine what you cannot see. For every star visible to your naked eye, there are another 10 million hiding in the same galaxy. 100 billion stars in our Milky Way alone, most of them older than our sun, many of them with planets. And as far as anybody has been able to tell, none of them are saying a word. The sky is silent. That ought to disturb you, not in a small way, in a big way. Because when you work out what the silence means carefully, step by step, using nothing but physics, you arrive at one of two conclusions. Either something we do not understand is going on with the universe, or something we do not want to understand is going on with the universe. I want to walk you through both, because this puzzle is one of the oldest and best puzzles I know of, and the candidates for an answer are not a gentle bedtime story. My old friend Enrico Fermi asked the question out loud first, as far as I know. He was having lunch with some colleagues at Los Alamos, and the conversation wandered to flying saucers, which were in the newspapers at the time, and then wandered to the broader question of whether there might be other civilizations out there. Fermi listened for a while. He chewed on it, and then suddenly, right in the middle of the conversation, he stopped and he said, "Where is everybody?" That was 1950. He was not making a joke. He had just done the math in his head, and the math did not add up. The stars are too many. The time available is too long. The silence is too complete. Something was wrong with the picture. And in the years since, the more we have looked, the more wrong it has gotten. We are going to figure out what. First, let me give you a feel for the numbers, because without the numbers, the argument is a pile of words with nothing under it. Our galaxy contains roughly 100 billion stars. Some people say 200 billion, some say 50. Take any number in that range. It makes no difference for what I am about to say. There are plenty. How old is our galaxy? About 13 billion years. How old is the universe? A little older, around 13.8. How old is our sun? 4.5 billion years. Our sun is, by galactic standards, young. Relatively speaking, we live on the front porch of a very old house. The galaxy had been doing its job, forming stars, cooking heavy elements, building planets, for 8 or 9 billion years before the sun ever lit up. Think about what 8 or 9 billion years means. Here is one way to see it. The universe produced us starting from hydrogen. That took 13 billion years, from the beginning all the way to you sitting there, reading equations or watching this lecture. If the universe had needed another 9 billion years to warm up before we showed up, it had enough leftover time to build us twice, maybe 2.5 times, with time to spare for lunch in between. Other civilizations out there could have gotten a head start on us of millions of years. 1 million years is a long head start. 1 billion is hard to even imagine. Let me try. 3,000 years ago, human beings were figuring out how to smelt iron. 150 years ago, we were starting to harness electricity. 70 years ago, we left the Earth for the first time. That is the full run from bronze tools to rockets, and the whole thing fits inside 3,000 years. Now imagine a civilization 1 million years ahead of that. Not 3,000. 1 million. What do they know? What can they do? I cannot tell you. Neither can anybody. But whatever it is not nothing. And 1 billion years ahead? Forget it. You and I are not equipped to think about that. How many such civilizations should exist? Here is where the numbers start to pinch. Suppose life is rare. Suppose of all the stars in the galaxy, only 1 in 1 million produces a civilization capable of looking up and asking this question. 1 in 1 million out of 100 billion stars is still 100,000 civilizations in the galaxy. Make it 1 in 1 billion. That is still 100. 1 in 100 billion? 1. That would be us, and nobody else, ever, in the entire galaxy. We do not know the real number. But for us to be alone in the galaxy, the chance of a civilization arising at any given star has to be close to 0. Not small, essentially 0. anything bigger than that, and there should be company. So let us assume, for the sake of the argument, that we are not a uniquely special accident. Let us assume at least a few civilizations have emerged out there, somewhere at some point in the long history of the galaxy. Where are they? We keep tightening that question until it hurts. Here is the second piece of the puzzle. Let us ask a simple thing. Suppose just one civilization, not all of them, just one, decided to spread. Not to conquer anyone, not even to contact anyone, just to send its descendants, or its machines, from one solar system to the next over many generations. The way you might imagine a species of bird working its way from one island to the next over a very long time. How long would it take such a civilization to reach every part of the galaxy? The galaxy is about 100,000 light years across. Light itself takes 100,000 years to cross it. Nothing physical can go faster than light, but anything physical must go slower. So let us pick a speed. 1% of the speed of light. That is crawling, by cosmic standards, much slower than anything we think is impossible. At 1% of light speed, crossing the galaxy takes 10 million years. 10 million years. Compare that to the age of the galaxy. The galaxy is 13 billion years old. 10 million years divided by 13 billion is about 1 part in 1300. If you took the entire history of the galaxy and compressed it into a single day, 10 million years would be a minute and 6 seconds. Just over a minute. So a civilization, moving at 1% of light speed, fills the galaxy in roughly the time it takes to lace up your boots on a cosmic clock. And I was being slow. 10% of light speed is not obviously impossible. Even 1/10 of 1%, still many times faster than any spacecraft we have ever built, covers the galaxy in 100 million years. Still a blink. Think about what this means. For the galaxy to be empty today, you need every civilization that ever arose, across 13 billion years, across 100 billion stars, to have not spread. Ever. Not at all. Not accidentally. Not even a little bit. Because if a single civilization at any time ever got the urge to expand, even at a snail's pace, the galaxy would have filled up long before you or I were born. Long before the dinosaurs. Long before the first cell on Earth. We would not be searching for them. We would be digging them up. We would be finding old outposts on asteroids. We would be picking up radio chatter from settlements a few stars over that had lost contact with the home world a million years ago. Something. Anything. A useful image. Drop a drop of ink into a glass of water. Do not stir. How long does it take to spread? A few minutes. The glass is a few centimeters across. The drop moves at about a millimeter a second, and diffusion handles the rest. Scale that up. The galaxy is the glass. Civilizations are the drops. There have been, potentially, many drops over cosmic time. Even the slowest drop spreads faster than the glass is old. And yet, the water is clear. No ink. Nowhere. That is not a small problem. That is a very large problem. Fermi's question is asking about that problem. Not where is the nearest alien we might talk to, but where is the evidence that anyone, ever, anywhere, did anything? Let me tighten the screw further. Some of you might be thinking, well, maybe civilizations do not like to travel. Maybe biology is fragile. Maybe living creatures cannot survive 1,000-year journeys between stars. Cellular repair is tricky. Radiation is a killer. Breeding populations are hard to keep going. Fair points, all of them. Maybe civilizations never go in person. But they do not need to go in person. A mathematician friend of mine, John von Neumann, worked out a gorgeous idea years ago. The idea is a machine that does two things. The machine does some useful task. The machine also builds a copy of itself out of whatever raw materials it finds nearby. Rocks, ice, metals in asteroids. Give the machine some instructions, give it time, and it makes another of itself. Send the copy to the next star. That copy makes 2 more. The 2 make 4. The 4 make 8. You know about doubling. Doubling is the fastest kind of growth we know. 2, 4, 8, 16, 32. After 10 doublings, 1,000. After 20, 1,000,000. After 30, 1,000,000,000. After 40, 1,000,000,000,000. After 47 doublings, you have more copies than there are stars in our galaxy. So how long does a self-replicating probe take to fill the galaxy? The travel time between nearby stars at modest speeds is a few hundred to a few thousand years. Let us be generous and say each generation, travel plus replication, takes a full 1,000 years. 47,000 years to do 47 generations. 47,000 years. In 47,000 years, a single civilization, in a single star system with a single engineer building a single prototype, could cover every star in our galaxy with its descendants. Every star, every planet, every moon, every asteroid, every ball of ice in every lonely outer system. And the cost? Nothing, essentially. You build one machine. After that, the machines build themselves. They mine what they need. They travel on their own. The first machine is the only investment. Everything after that is cosmic compound interest. So if even one civilization, ever, anywhere in our galaxy over the last 13 billion years, had the idea of self-replicating probes and acted on it, the probes should be in our solar system right now. They should have arrived long before we did. They should have watched the dinosaurs come. They should have watched the dinosaurs go. They should have watched the first fish crawl out of the sea. They should be watching us. What would such probes be doing? Whatever their makers told them to do. Mapping, observing, reporting back, mining, building more probes, building other things. Whatever it is, it would be ongoing. It would be active. It would leave fingerprints. Modified asteroids, strange signals between machines, anomalous infrared sources where no infrared ought to be, observed over a long enough time, changes that nobody's physics textbook can account for. We have looked. We have scanned the sky in every direction we know how. We have searched for anomalies. We have looked at the asteroids. We have looked at the moons of the giant planets. We have not, so far, found any trace of any such thing. Some people argue maybe the probes are small and polite and they just watch and they leave no trace. But this argument has a weight problem. For it to work, every civilization that ever built a probe and every probe ever built has to have the same discretion. All of them. Or nobody ever builds them in the first place. Since the probes are cheap and the idea is obvious, it is hard to believe nobody ever built them. Somebody would have, somewhere, and the result would be visible, unless nobody ever did. Unless the kind of civilization that would build probes does not exist, or does not exist for long. Can you feel that? That small chill on the back of your neck? Every piece of evidence we accumulate points the same direction. Either civilizations are unbelievably rare, or something is happening to them before they spread. Keep pulling. Let me tell you about something that no civilization, however advanced, can hide. Waste heat. Every time you do useful work, you produce heat. When the refrigerator cools the food inside, it warms up the kitchen. When you run a computer, the processor heats up. When an animal walks around, it radiates body heat into the air. This is the second law of thermodynamics, and there is no way around it. There is no technology that will ever be invented, no clever trick that lets you do work without producing waste heat. It is built into the structure of the universe. Freeman Dyson, who is a friend of mine at Princeton, pointed this out some years ago. He said a civilization that grows large enough will eventually be using a very large fraction of the energy its star puts out. Maybe they build structures around their star to catch that energy. Clouds of collectors, swarms of panels. You do not need to see the structures. You just need to notice the star is behaving wrong. Instead of shining at the colors of a hot surface, the star will be shining mostly in the infrared. Warm, but not hot. The signature of a star whose energy has been harvested and dumped back out as waste heat. We have looked at millions of stars, catalogs of millions. We have looked for exactly this signature. We have not found it. Not around our nearest neighbor. Not anywhere in our sweep of the galaxy. You might say, maybe they are efficient. Maybe they do not need that much energy. But efficiency has a ceiling. You cannot compute without producing heat. You cannot build structures without losing some energy to radiation. Even a civilization that wanted to be invisible would be radiating heat. Not a lot, but some. And we would see it in the right part of the infrared sky. We do not. Look beyond our galaxy. There are, at a minimum, hundreds of billions of other galaxies in the observable universe. We can see a lot of them. Some of them we see as they were billions of years ago, because the light took that long to reach us. We are looking at an enormous sample of places and times. You would think, somewhere in that huge sample, some galaxy would have been colonized by an ambitious civilization, and the whole galaxy would look wrong, shifted toward the infrared, unusual, peculiar. We see none of that. The galaxies we see behave exactly the way physics predicts for galaxies that contain no engineering projects larger than natural objects. No cities around stars. No swarms of collectors. No industrial processes at the scale of star systems. The universe we can see looks untouched. 100 billion stars in our galaxy. Hundreds of billions of galaxies beyond ours. 10 billion years of opportunity. And the whole thing looks like a freshly set table. Plates laid out. Nobody has sat down to eat. Nobody has even pulled out a chair. This is what needs explaining. Not just local silence, cosmic emptiness. Let us go through the candidates for an answer, one at a time. Candidate 1. Maybe life itself is rare. Maybe the chemistry that leads from dead molecules to something that copies itself is so rare, so improbable, so fragile, that it almost never happens. The galaxy is empty, on this view, because life almost never gets started. This is a respectable candidate. I do not want to brush it off. We really do not know how life began. The jump from a collection of organic molecules sloshing in a puddle to something that copies itself is a jump we have never observed. We have not reproduced it in the laboratory. We do not know how likely it is. It might turn out to be absurdly improbable. We might really be the only inhabited planet in the visible universe. If so, the silence explains itself.